Good morning, student. Today we will do an experiment of VLSI Lab. So, aim of the experiment is develop a VHDL test bench code for MOX circuit. Then equipment required, that is Xilinx ISA software and personal computer. So what is a multiplexer? Simply we know that multiplexer combines number of input signals and the output it gives single output. Okay. So this one is the diagram. Here we are discussing about 4:1 multiplexer. So I1, I2, I3, I4. 4 inputs are given, and for 4 input lines here 2 select lines are used, that is S1 and S2, and at the output we get combined output. So how it works? S1 and S2 2 select line means we can get 4 input combination. So when S1 is 0, S2 is 0, then at the output we get I1, means I1 value we get at the output. So I1. When S1 and S2 is 0, 1, at that time we get the value of I2 at the output. So that is I2. Then when S1 is 1 and S2 is 0, then I3 is connected to the output, and at the output we get the value of I3. So I3. Then last combination, that is 1, 1. When S1 and S2 is 1, 1, at that time I4 is connected to the output, and the output we get I4 value. So here we can write I4. So the equation, that is output equation, can be written as y equal to S1 bar S2 bar means 0, 0. So it is written as complement I1 plus 0, 1 I1 complement S2, that is into I2, plus 1, 0 means S1 S2 complement, that is I3, plus 1, 1. So S1 S2 I4. So this one is the final equation or output equation of a 4:1 multiplexer. So in the VHDL programming we just write Y assignment operator, not S1 and not S2 and I1, then OR. So plus is represented as or not S1 S complement, that is represented as not S. Okay, so not S1 and S2, here these are multiplied with each other, so that is we can say AND. So not S1 and S2 and I2, or S1 and not S2 and I3, or S1 and S2 and I4. So we write the functionality like this in the VHDL programming. When we try to represent the equation using a logic diagram, then the logic diagram consists of 3 input AND gates. So how many AND gates are used? 4 AND gates are used and 1 OR gate. This one is the AND gate, this one. So here 3 inputs are given like this, that is I1 0, 0, then I2 0, 1, then I3 1 0, then I4 1 1. 0 0 means S1 complement S2 complement, like this. 0 1 means S1 complement S2, then 1 0 means S1 in and S2 complement, 1 1 means S1 S2. Then we combine this outputs using a OR gate, and finally we get our output here, that is Y. Okay, let's do the experiment using ISC software. Okay, so for the experiment of 4:1 mux, first we open the software. Then add a new source and select VHDL module. Then give the name mux. Then next, here we give the mux input. So as we know, mux has 4 input, as here we are using 4:1 mux. So here we give I1, I2, I3, I4. Okay, then select line, as 4 inputs are given, that means 2 to the power 2 means 2 select line. So S1 and S2. Then one output, that is given Y. Okay, so here we change it to out. Then next, finish. So this is the program, and here inputs are given and output is given. Here we declare the functionality. So we know the equation, output equation of mux, that is Y assignment operator not S1 and not S2 and I1 bracket close, then OR bracket start not S1 bracket close and not S2 and I2 bracket close, or S1 and not S2 and I3 bracket close, or last term, that is bracket start S1 and S2 and I4 bracket close, colon, semicolon. So the equation is Y equal to S1 complement S2 complement I1 plus S1 complement S2 I2 plus S1 S2 complement I3 plus S1 S2 I4. Okay, so the program is complete. Just check syntax. Green tick means there is no error within this program. Then we view the RTL schematic. Click on OK. Then here we can see the schematic. So I1, I2, I3, I4 are 4 inputs, 2 select line, that is S1 and S2, and 1 output, that is Y. Then double click here. So as we already discussed about the logic diagram, the diagram consists of 4 AND gate and 1 OR gate. Okay. Next we go to the simulation part. So for simulation, we add a new source, that is VHDL test, then mux underscore TB. Next mux, next finish. Okay, then click here. First we have to change this programming. First we just remove this, then here we copy the test bench programming. 1 second. So first one is the library part, that is include the library. Then we define a blank entity, this one, blank entity, as a test bench does not define actual hardware. Okay, then we declare the components, these are the components. Then we declare, we have to port map, this one. Here we do the mapping. Okay, then here we give the inputs so that accordingly we can get our output. Okay, so here we set the value of I1 to 0, I2 to 1, I3 to 0, then I4 to 1. Okay, so if we want to change these values, then we have to again change these values in the test bench programming. Here we give a fixed value to these 4 inputs. Then this one is the 4 combinations of S1 and S2. So now we check the syntax for this program. Here you can see a green tick, that means program is correct. Then we simulate the behavioral model to observe the waveform. See here. Okay, as the value of I1, I2 and I3, I4 that are given in the test bench programming, that is 0, 1, 0, 1. Okay, next just drag this pointer and see S1 and S2 is 1, 1. So when S1 is S2 is 1, that means at the output we get the value of I4 means 1. Then see here, when S1 and S2 is 1, 0, then we get the value of I3 at the output. So see here, I3 is 0 and Y is 0. Just change the position of this. See here, S1 is 0, S2 is 1. That means we get the value of I2. That means I2 is 1 and similar value, that is Y equal to 1. Okay, means the programming is perfectly working. So this is all about 4H2 1 marks. Thank you.